In this video we are going to talk about the resolution of forces. Okay, now this concept strictly comes from vectors. Okay, we'll try to recall it and apply it. So let us say we have a force F, and we have to find its component. Okay, this force component we have to find, or we have to resolve the force. So what we do, that at the tail of the vector we draw two axes. Let us say this is x-axis and this is y-axis, and suppose this angle is theta. Next what we do, we draw perpendicular from the head of the vector on x. Now this is the x component of the force, and same way we drop a perpendicular from head to y, and this is the x component of the vector and this is y component. We'll know that this is f. So if you use right angle triangle concept and you use cos function, you are going to find this component will be f cos theta and this will be f sin theta. Okay, this is the basic. Now let us apply in a simple case. Okay, let us see whether we can apply this in a simple case. So let us say we have a pendulum and it is oscillating, and at one instant let us say it is making angle theta at its extreme. Now first question is, draw what are the forces acting on the pendulum, right? So we all know that this there will be a tension on this pendulum in this direction along the string. Tension always acts along the string, and weight, suppose this bob has mass m, so mg will act perpendicular to the surface of the earth. Now let us say we have to resolve these forces, right? So what we do, we draw we draw let us say x-axis here, and this is our y-axis, let us say. So we all know that this angle will be theta, right? Huh? So if I drop a perpendicular from here on this, if I drop a perpendicular from here on this, so this will be x component of tension. If I drop a perpendicular from here, then it will be y component of the tension, right? So again, going by the same rule what we discuss here, this will be t cos theta and this will be t sin theta. Fine. Now let us say that we have a block here in the next example, uh, and this is acted by a force in this direction, let us say f, and this is making an angle theta, let us say 30 degree with horizontal. So what will be the component of force? Again what we do, we say that this is, let us say, one axis, this is another axis. So this is the direction of force. So if I drop a perpendicular here, this component is going to be f cos 30 and this component will be f sin 30. Okay, fine. Now the best thing to learn resolution is to learn how to resolve forces in inclined plane. So we are going to do that. Here we have an inclined plane and one block m, let us say, is resting over it. We are going to write m for the mass of the block. Now what happens if I draw, if I have to resolve it, uh, let us choose our axis first. Let us say this is our x-axis, which is parallel to the plane, and this is y-axis, which is perpendicular to the plane. So we want to resolve all the forces acting on this block along x and y axis. Okay, so axis is parallel to the plane and y axis is perpendicular to the plane. Now let us do the same here. So let us say this is our x and this is our y. Now let us talk about the forces. Now we all know that if this block is stationary, then friction must be there. If there is no friction, it will slide down. And in the earlier video we talked about that the friction on this will be in this direction. So this is the direction of friction. This is the contact surface, and there will be a contact force due to inclined plane on this block, which will be perpendicular to this surface, right? Then we can also say that this is earth, right? And weight will act perpendicular to the surface of the earth, right? So this is mg. Now let us try to resolve it. Now in this case you have to understand that this angle is going to be theta. Okay, now let me clarify it a bit. Why this angle is theta? It's very easy to do. So suppose I draw a line parallel to the ground. Okay, so this line is parallel to this ground. You all will agree that this is theta, alternate interior angle, right? Huh? And this will be 90 minus theta. Why? Because this line and this line are perpendicular, so this will be 90 minus theta, right? Right. So this angle is going to be 90 minus theta. Now we all know that this line and this green line should be perpendicular, so total angle between this should be 90. So this must be theta. Is it okay? So it's easy to figure it out. Now once we did that, let us just remove this, and now if I drop a perpendicular here, so, and if I drop a perpendicular here, so you can figure it out. This will be mg cos theta, and this side it will be mg sin theta, right? So this is the resolution of forces acting on this block parallel to the incline and perpendicular to the incline. Okay, now let us resolve it along. So let us draw one incline first, and now in this time what we are going to do, we are going to resolve the forces. Let us say this time we are choosing the normal axis. So we are going to say that this is our x-axis and this is our y-axis. Okay, now this is horizontal and this is perpendicular, the general way what we draw x and y axis. Now in this case how we resolve it? So again let us say we all know that if I extend this y, this y will be perpendicular to the ground, right? No? So mg is acting in this direction, we know that. Now friction is acting in this direction, and we know that normal force acts perpendicular to the surface. So this is the normal force R, right? Now we all know that this angle is going to be theta. What about this? This will be 90 minus theta, right? This angle will be obviously 90 minus theta, and this angle is going to be theta. Okay, again, this x and y axis are perpendicular, so if this is theta, this is not, this must be theta. Fine. So we are going to remove this now so that it looks clear. So this angle is theta. In this case, if I drop a perpendicular here, and if I drop a perpendicular here, right, and if I drop a perpendicular here, sorry, this shaded line you can ignore. Okay, let me remove this. So if I drop a perpendicular here, and if I drop a perpendicular here, this angle is theta, so this side will be r cos theta, and this component will be r sine. So make sure that you practice this diagram, okay, and ask any doubts whatever you have. Once you have understood this resolution, I guess it's very easy to work with Newton's laws of motion. Okay, so see you in the next class.